Hello, welcome to the third lecture of statistics. Today we are going to talk about the topic dispersion or spread following the lesson on population in sample and central tendency. Once again, at the end of the class we will have practical examples given in Excel and Python. In statistics, dispersion, also called variability or spread, shows how much a set of data varies around a single point of central tendency. If you remember correctly from the first class, the central tendency tries to find the middle point. Therefore, the dispersion attempts to compute how spread out the data is around this typical or average point. It can be said that dispersion is a phenomenon that occurs when the values of a set of data are spread out in relation to their mean. In other words, dispersion measures how far the data is from the central value. Several measures, or metrics, try to capture this concept in the best way. As with central tendency, some measures work better in certain contexts than others. Here I present a non-exhaustive list of dispersion measures: range, variance, standard deviation, coefficient of variation, and interquartile range. While these measures have their utility, today we will focus on four measures. The first four measures: range, variance, standard deviation, and coefficient of variation. Let's start by discussing the usefulness of the measure range. The range of a set in statistics is the difference between the largest element of that set and the smallest. In other words, to find the range of a list of numbers, simply subtract the smallest element from the largest. Let's see this with an example. Suppose that two students, Maggie and Flanders, had the same average grade at school, 14 out of 20. Maggie's grades were 16, 14, 14, and 12. Flanders' grades were 9, 10, 18, and 20. Will it be possible to determine which of the two students had the most regular grades? In the example, there are two ranges to be evaluated: that of the first student and that of the second student. Maggie has 16 as the best grade and 12 as the worst. Her range of grades was 16 minus 12 equals 4. Flanders had 20 as the best grade and 9 as the lowest. The range of his grades was 20 minus 9 equal 11. These results already say that the variation in Maggie's grades was much smaller than Flanders, and that Maggie is a more regular student. In addition to the range, there are two very popular dispersion measures: variance and standard deviation. These measures allow you to calculate how much data from a set of values can vary. The variance allows you to determine the deviation from the mean. To do this, the average value of the squared differences from the mean is determined. The formulas used to calculate variance depend on whether you are analyzing a population or a sample. The standard deviation is calculated from the variance, as it is the square root of this parameter. The formulas used to calculate standard deviation depend on whether we are analyzing a population or a sample, as in the case of variance. So, let's see the formulas used. The variance of a population is calculated with the following formula. This formula is calculated from the following steps. Step 1. Calculate the average of the data. Step 2. Subtract the average of each data point. These differences are called deviations. Data below the mean will have negative deviations, and data above the mean will have positive deviations. Step 3. Square each of the deviations to make them positive. Step 4. Add up all squared deviations. Step 5. Divide the sum by the number of data in the population. The result is called variance. Let's see that for a sample, the formula is different. The variance of a sample is calculated with the following formula. First, we calculate the arithmetic mean of the set. Then we subtract the calculated mean or average from each value in the set and square the result. And finally, we add up all the values and divide by the number of data minus 1. Note the difference in terminology of these two formulas. Importantly, sigma squared is for the population what s squared is for the sample. An interesting topic concerns the reason why we divide by n minus 1 in the formula. Here is a brief explanation. In the sample formula, we deal with incomplete set and estimated means. The smaller the sample, the more we tend to underestimate the differences to the mean. To compensate for this situation, we divide by n minus 1 to obtain a variance value closer to the real one. This is the so-called Bessel correction. If the number of elements in the sample is large, division by n or n minus 1 gives approximately equal values. The standard deviation formulas can be quickly derived from the previous ones by applying the square root. It is important to see these concepts with an example. Here, we have this week's temperature throughout the day for the islands of Madeira and Açores. For example, on Monday, we had 23 degrees Celsius in Madeira and 19 in Açores, and so on. We want to know more about the temperature phenomena in these two regions this week. Calculating the mean, we see that Açores had a lower average temperature than Madeira. Calculating the standard deviation and variance, we see that Madeira had greater temperature variation, 1.4 standard deviation, 2.2 variance, than Açores, 0.9 standard deviation, 0.75 variance. Fortunately, due to the calculation of the standard deviation, we have an idea of the variability of temperature that is closer to degrees Celsius. It is important to explain why variance is not as useful in this context as standard deviation. The variance is not represented in the same units as the observations due to the expression having a square. For example, if the sample comes in meters, then the variance comes in meters squared, which is not easy to understand in all situations. To address this problem, we can use the standard deviation. This measure has the advantage of using the same units as the observations due to the root of the algebraic expression. Perhaps this explains the greater popularity of standard deviation compared to variance. Let us now talk about the relative measure of sample variability, the coefficient of variation. This measure is useful for comparing the spread of data around the mean when we deal with different samples. The coefficient of variation is equal to the standard deviation divided by the mean multiplied by 100. Since the coefficient of variation analyzes dispersion in relative terms, it is given as a percentage. The smaller the value of the coefficient of variation, the more homogeneous the data will be. That is, the smaller the dispersion around the mean will be. In general, if the coefficient of variation is less than or equal to 15%, then we have low dispersion and homogeneous data. If it is between 15 and 30%, then we have medium dispersion. If it's greater than 30%, then we have high dispersion and heterogeneous data. For comparing datasets with different units or very different means, the coefficient of variation should be used instead of the standard deviation. Just note that when the average value is close to 0, the coefficient of variation approaches infinity. In these cases, this measure should not be used. Let us now try to materialize these concepts into practical examples in Excel and Python. Let's start with the scenery of the islands in Portugal, that is, Açores and Madeira. The climate is quite different in each of these archipelagos. In this Excel, we have the daily temperatures for a week in Açores and in Madeira. We want to know which climate is most unstable, according to temperature. We have in one column the temperature of Açores in Celsius and in another column the temperatures of Madeira in Celsius as well. Let's start by applying the range formulas to both sets of data. The easiest formula is to subtract the smallest value in the set from the largest element in the set. We have the range of 5 for Açores and 11 for Madeira. Let us then calculate the variance and standard deviation using the population formulas. Let us assume we only want to study this exact week, so that's why we use the population. We obtain the same result as for the range. The standard deviation in variance is greater for Madeira. What we can calculate is the coefficient of variation. The formula is simple: standard deviation over mean multiplied by 100. Once again, the measure confirms our expectations. 10% indicates that the Açores climate is less unstable than the 18% dispersion of data in Madeira. Let us look at a brief example in Python. In this example, we have to import packages. Once again, we have our well-known NumPy and SciPy packages. Then we have to define a vector of data with numbers. We calculate the range as the minimum value subtracted from the maximum value. The standard deviation and variance are calculated with the NumPy package on the vector. The coefficient of variation is calculated from the formula. Thank you for staying with us, and see you soon.